Good evening, folks. So today we're looking at proving trigonometric identities. So first of all, if you have not done simplifying trig identities, you might want to kind of take a look at doing something like that first before looking at this. But what you're trying to do in this case is to show or prove or verify that you have the left side of an identity equal to the right side of the identity. Okay. And when you prove, you're trying to make and use all your identities to make the left side look just like the right side. Or in some cases, the right side look like the left side, depending on what it is. One of the tricks is to actually work with the side that looks a little bit more complicated to do, because once you start simplifying one side of it down, it could be that you realize and recognize how they both connect to each other. Okay. So that also means being familiar with your different possibilities. Okay. And again, I highly strongly suggest having identities, in front of you when you do this to make this a little bit easier. So I'm going to go through, I'm going to show you kind of how to look at it. And the one thing about this is, again, there's really could be multiple ways of doing or proving that it works. What makes this, in my opinion, a little bit simpler than simplifying is you actually know what the end product is supposed to be. So in other words, if I would have started with this and kind of simplified it down, I could have come across, another possibility. Here, you at least know that the end product is supposed to be cosecant. So, and I apologize if I'm sniffling a lot right now. So here's kind of the way you look at it. And again, I'm going to go through, I may not get through all of these this time around, but I will at least show you as much as possible. And then I will, give you a chance to work on them, and then I'll post the answers, what they look like. Hopefully you try them before you look at what I do. So, all right. So here's what I'm looking at here. I'm going to work the left side of this and try and make it look like the right side. And kind of a trick again is to make everything either sine or cosine. That way you are only really trying to work with, one or two different identities. The other part to it also is to know that you can use common denominators. You can use multiplying. You can use factoring. You can even break fractions apart. And I'm going to find one that actually does that and do want to show you how that actually works. So anyway, so what I'm going to do first is I'm going to look at this, and I see a sine, I see a cosine. This cosecant, however, I'm going to change it. I want to make sure and change it to the reciprocal of 1 over sine. So that's what I'm going to do. I'm going to make this become 1 over sine. And again, understand, I will probably not write every single angle symbol down, just because for me, I'm not used to doing that. And then once I do that, then I actually can multiply these two terms together to get cosine squared over sine plus sine, kind of like that. Okay. Now, I can't actually add these together. What I can do, though, is make this a common denominator by multiplying this side by sine, because this is basically the same thing as sine over 1. And what I end up getting is the cosine squared over sine plus sine squared over sine. And then I can go ahead and add these together. And again, all of this is going to eventually equal cosecant, kind of like this. Now, I know I haven't been writing that down all the way through, but I'm just kind of getting to it. Cosine squared plus sine squared is a Pythagorean identity, which cosine squared and sine squared is equal to 1. So this whole thing is going to become 1 over sine theta, which 1 over sine theta, 1 over sine angle is equal to cosecant. So this becomes cosecant, which is equal to cosecant. And you've proven the two sides together. So when you prove, that's essentially what you're trying to do. I'm going to kind of fill this out a little bit so you can kind of see how I keep tracking this down all the way through. Okay. And that's kind of how you prove it. That's how you verify that the left side is equal to the right side. Okay. So I'm looking at number 2. And again, you have options. You can either work with this side, you can work with this side. And again, depending on what your preference is, some people might say do the left side, some people might say do the right side. So one thing I know about this is the fact that secant here is the reciprocal of 1 over cosine. So since that's actually a cosine in my denominator, and I see the cosine here in my denominator, I know that there's a way to get this using cosine as a denominator, okay, which is actually what I'm going to try to do. So I'm going to do the left side on this because I'm looking at it and I'm trying to think, is there a way to get cosine all the way through? And there is, because secant sine squared is a Pythagorean identity. Which one is it? It's sine squared. Oh, right here, sine squared. Sine squared is equal to 1 minus cosine squared. And so what happens is I'm able to get this top part and make it become 1 minus cosine squared. Oh, this is a y now, not a theta. Sorry. Over cosine, and that's going to be equal to secant y minus cosine y. Okay. And again, the reason why I'm doing this is because I know that this part right here is 1 over cosine. So since there's a cosine in my denominator, there's a cosine in my denominator right here also. And here's where breaking apart your fraction really works. First of all, make sure your numerator is 1 plus or minus a particular piece. That's the only way you can actually break this down. If your denominator wasn't like that, like this, then that means you're doing common denominators instead. So what I can do right here is break this down where it's 1 over cosine of y minus cosine squared of y over cosine, kind of like that. And right off the bat, now here's what I'm actually looking at. Again, because I know secant was 1 over cosine, here's my 1 over cosine right here, which will become my secant of the angle, minus, and then cosine squared over cosine reduces, where you cancel your denominator, cancel the square, so all you have left is cosine of y, and that's going to be equal to the secant minus the cosine. Okay, so I verified again that piece. Okay, looking at number 3 and looking at number 4. Okay, number 3, again, here's kind of what I'm looking at. There's a left side, there's a right side. And what you want to kind of determine is what is the relationship between this cosine and this sine squared. Well, the fact is this. Cosine squared is also, again, Pythagorean. And what I know is the fact that the cosine is equal to 1 minus sine squared. Okay. And so I'm going to write that out here just to kind of help me out, because it's 1 minus sine squared is what that is going to be. I'm really going to work this side out right here. And again, there's a couple ways I could do this, and I'm looking at what the easiest way to do this would be, because I'm thinking to myself, well, I could factor out the sine squared since I see 2 of those and make this cosecant minus 1, which if I did that would become a cotangent. However, that's probably going a little bit off the rails from what I really want. But the other thing I also know is this sine squared right here, cosecant, I'm sorry, is the reciprocal of sine right here. 1 over cosecant is equal to sine squared. So I can make this the right side, where you have sine squared of the angle, can't write an A all of a sudden, times 1 over sine squared of the angle minus sine squared. And here's why that's important. because this is what I'm trying to get at. And I see right here, if I multiplied these two together, that would reduce to that would reduce. And what I end up with is 1 minus sine squared of the angle. Okay, that's very bad A. And again, since I knew I was trying to get to this right here, and I see this sitting right here, then I know that this verifies out to the cosine squared of alpha, kind of like that. So again, different ways of doing it. That was probably the easiest way to do it. The other way I think if I would have tried it, where I had sine squared and then made it cosecant minus 1 for cotangent, I would have actually come up with the same answer. But, you know, and I might try that next time around. Number 4, I'm looking at number 4, and the one thing about cosine that I know for sure is that it's got a couple of relationships. One is 1 over secant. And the reason why I know that is because right here I see a secant here. So like this one right here is 1 over secant. Okay, that's the relationship from that. And the reason why I'm looking at that is because right here, I see the secant sitting in my denominator right here, which means that I want to probably try to get this to where it becomes a 1 over secant. And so doing that, there's a couple of ways I could do this again. And I think the easiest thing to do would be to take the left side of this and go ahead and do my common denominators right here in the instant. Sorry, you can't see that. My common denominators, and before I do anything else. So here's what's going to end up happening. Let me write this. So if I multiply, let me try. So if I multiply this side by tan, I multiply this side by secant, I end up with the tangent of x times secant squared over secant tan minus tangent squared over secant tan, kind of like that. Okay. And the reason why I'm doing that is because, again, I still keep my secant in my denominator, which, again, I'm trying to get to this right here. But what I notice is this right here. Secant minus tan squared is actually a Pythagorean identity as well. And right here, and I don't have my variation written out right here, but basically subtracting tangent to this side gives me just a 1. And so what I end up having is the fact that I have this tangent still sitting out here. And now that's going to be equal to 1 over my secant tan, kind of like this. It's equal to cosine x. So then, again, if I distribute this through, this is going to reduce this guy out right here. And I end up with 1 over secant here, which, again, was what I was trying to get to begin with. So then now this verifies to be cosine, which is equal to cosine. So there's my verification. And again, I was thinking about going about where I could go ahead and distribute this through here and here, make this a tan squared already. Then I would have had a secant tan here, a tan secant, which I would have had to do a little bit more than what I probably really wanted to. But I would have gotten there as well. Okay. Let's look at these two right here. And again, I'm looking at this and I'm trying to decide how best to approach it. If you want to pause at this point and try one, I will come back here with the answers in a second. So you can at least maybe see what you can do. I will give you a hint on this first one, though. You can GCF this cosecant out because I'm looking at cotangent right here. And one thing I know about cotangent is the fact that cotangent is the same thing as cosine over sine. And so if I can find a way to make these cosines, which cosecant is no, I'm sorry. Let me rephrase that. Cosine is secant, so there's got to be a way to make this into cosine. Okay. I also know that cosecant and sine are reciprocals of each other, which is what I meant to say a minute ago. So that's that. And then tangent, the rule, the kind of the trick on this one is the fact that I know that secant is 1 over cosine, which means is there a way I can get from here to even get to this step on these? And I'll also even give you a hint on these is the fact that if you know your even odd functions on these, it actually will help. The even odd functions are, I don't have them with me right now to show you, but I'll come back here in a second. Anyway, so try and pause them. I'll be back here with the solutions on them. All right, folks, here we go. First one here. I went ahead and factored out this cosecant to make this 1 minus sine squared, which then you get cosecant squared. When it multiplies together, I end up with cosecant squared over sine squared. This is a multiply right here. I didn't put a multiply, which is cotangent, which is what I was trying to get at. So right here, I knew this was cosine over sine, so that's what I was trying to get at. Here, I knew that secant was 1 over cosine, so I had to figure out a way to get there using that. And so what I noticed, first of all, that I have these even odd functions here. So I turned tangent of negative angle to a negative tangent of the angle. Same thing with the sine. And then the cosecant, because it's an even function, became a cosecant of the angle itself. Then I went ahead and turned sine into sine over cosine because, again, one of my rules is if you can make everything sine and cosine, it probably will work out pretty easily, which I did. Because then I was able to multiply this sine and this sine to make this a positive sine squared. Okay. Then I end up with common denominators here, so I multiply this side by cosine to get sine squared and cosine squared, all over cosine, which is my common denominator. Sine squared and cosine squared is a Pythagorean identity, which becomes 1, and therefore there's my 1 over cosine, and there's my 1 over cosine, so there's my verification. Okay. That one was a little bit trickier, but, not too bad. So I'm going to look at these, and let's see what this looks like. So I want to figure that part out right there. Let's see. How do I want to do this? Do I want to do the left side or do I want to do the right side is the problem. If I do the left side, I know it's going to become this right here, unfortunately, is not cosine squared, according to the Pythagorean identity. So it's not going to do what I want it to do, because it has to be minus. Okay, so that's not going to work what I want to do with that. Okay. Matter of fact, what I do, and again, if you want to figure out what I'm trying to figure out here is this is going to be 1 minus, so it's not going to do me any good to do it that way. I'm looking at this 1 plus cosecant squared, and I'm trying to think, is there a way to do 1 plus cosecant squared? And I don't see one that does that, so I don't know if I want to do it that way. 1 plus cotangent squared. Well, okay. Well, 1 plus cotangent squared, good thing about that I know is that it's going to be cosecant squared. So that might be a possibility to do it that way. So let me look at it real fast, and I'll be back to show you how exactly I want to do it. All right. So that's what I did. It's actually a lot simpler than what I thought it was going to end up being. So yeah, I went ahead and changed 1 plus cotangent squared into cosecant squared. Then I broke apart my fractions to where I had 1 over cosecant squared and then cosecant squared over cosecant squared. This is a reciprocal, becomes sine squared. This becomes 1, and there's my verification. Bam. Not too bad. Now, here's the thing I want to show you that I want you to understand, because this is another way of doing the same thing. Sorry, this is my other work I was looking at. Notice how this looks a lot weirder, but they verify the exact same thing based on what I did in 2 steps. that does happen sometimes. Okay. And so you have to just, be patient with what you're trying to do and what you're trying to accomplish. So I look at number 8, and again, I'm looking at trying to figure out what's the best way to approach number 8. Do I do the left-hand side? Do I do the right-hand side? Look at number 9. Do I do the left-hand side, the right-hand side? Same thing with 10, right, left-hand side, right-hand side. And so there's a long way sometimes, there's a short way sometimes, depending on how you do it and what you recognize. But I would definitely say knowing and understanding your trig identities really helps a lot. And if not, at least have these to kind of stare at until you can kind of work out. But anyway, I'll finish these off. You can kind of see the answers to them, and then I'll come back. All right. So here's this one right here. And again, making everything sine or cosine to make this a little bit easier. And again, I'm doing that because I want to see the fact that I see this where this is sine, cosine. So everything becomes a sine and a cosine. Then on the numerator, I do some common denominators to get this. The denominator, I do some common denominators to get this. Sine squared and cosine squared is 1. So again, we never really divide fractions. We multiply by the reciprocals. So this becomes cosine sine over 1 instead, which again, this part and this part reduce out. So you end up with sine plus cosine. There it is. Okay. Number 9, sorry. This one was a little tricky because I was trying to think if there's a way to actually do based on the left-hand side. But one thing I know is I can always do conjugates on these. And that's going to help me work out the bottom part. But the idea is to make this become 1 minus cosine squared. So then what happens is that becomes sine squared here in the bottom. And notice on top, I was able to take the same thing and make it a 1 plus cosine squared. So instead of actually multiplying them out, the reason why I did that is because if I look at the left-hand side, it's cosecant and cotangent squared. So that means that I'm able to take this to make it look like this already. Your denominator becomes sine squared based on Pythagorean identities. And then I square everything. So what happens is this sine squared and this squared become 1 full squared term. Then I'm able to separate my fractions, 1 over sine and cosine over sine, which is where the cosecant and the cotangent come from. This one actually is a little tricky, and I know that, and that's why I was trying to see if there's a different way of doing it. But that's an interesting one. And then number 10 is just a doozy, period. And I can't believe I just used the word doozy, I'll be honest with you. But this one right here requires you to do common denominators again, kind of like this. And when you do that, you end up with the sine squared on top and then a 1 minus cosine squared on top here again, which is the idea. So then I actually multiply this part out to get this term, 1 minus 2 cosine squared, and that's not sine squared here. That's good because sine squared and cosine squared will become a 1. And the reason why I know I have to do this is because right here there's a 2 cosecant. I've got to get 2 somehow. 1 plus 1 is 2. There's another 2 sitting here also. So there's a possibility that this cosecant 2 is this going to be this cosecant 2. Anyway, so I end up with 2 minus 2 cosine y over this. Then I'm able to GCF or factor out this 2 here to make it 1 minus cosine. And then you can't see what I'm doing here, but I am... right here. Yeah. This 1 minus cosine here, that's what I did. And this minus cosine here, I can't see what I wrote, actually will reduce out. So all you're left with is 2 over sine, which becomes 2 cosecant. That's another tricky one right there as well. And that requires some different parts and understandings of when you multiply and when you don't multiply. So like 9 and 10, where I didn't multiply here, on number 10, you did multiply here. So it just depends on what you're trying to get at. I mean, but again, there it is. proving identities. That's essentially what you're trying to do. Enjoy, and we'll see you around.